This video covers everything we did in class today on Monday, January 4th, and I recommend watching it if you were stuck or confused in class, or if you missed the beginning of the session. So the first thing we did was we completed this ratio review problem in our notebook. It says, complete the question in your notebook. 1, while training for a race, Andre's dad ran 12 miles in 75 minutes on a treadmill. How long would it take him to run 8 miles at this rate? And 2 is how far could he run in 30 minutes? So go ahead and pause this video and give this question a try. So we talked a lot about finding the unit rate before break. And in this case, the unit rate that would be helpful to solve question 1 is going to be figuring out the number of minutes per mile. So the number of minutes it takes Andre to run 1 mile. We know that Andre's dad, 12 miles in 75 minutes, which means we can divide 75 divided by 12, which gives us 6.25 minutes per mile. And since I know that Andre runs 6.25 minutes per mile, to run 8 miles, I can simply multiply 6.25 minutes per 1 mile times 8 miles, which is going to give me the number of minutes it takes him to run 8 miles, or 50. Now, the second question says, how far could he run in 30 minutes? And the easiest way for me to think of this question is I'm basically splitting up 30 minutes into groups of 6.25 minutes, because that's how long it takes to run 1 mile. So 30 divided by 6.25, and it would be more precise for me to have labels there. I'm dividing 30 minutes by 6.25 minutes per mile. So splitting up my minutes into groups the size of 1 mile, the number of minutes it takes to run 1 mile, is going to give me 4.8 miles. So once we did that opening activity and kind of reviewed what we know about rate, we did a guided practice on speed. It says 20 minutes here, but it ended up taking us most of the class to work on a single problem. So I'm going to walk through that in this video, and this is a great resource, again, if you were at all stuck during class today. Given a constant rate, you should be able to calculate speed and pace, use unit rates to identify the distance traveled when provided the time elapsed, and find the time elapsed when given the distance traveled. And this is what your independent practice, exit ticket, and homework assignment really focused on. So on Desmos, you had this problem about Claire and Kieran. Kieran and Claire live 24 miles away from each other along the rail trail. One Saturday, the two friends started walking toward each other at 8 a.m. with a plan to have a picnic when they met. Kieran walks at a speed of 3 miles per hour, and Claire walks 3.4 miles per hour. So if you're following along and you weren't in class today, you should be on Desmos, and you should be ready to answer A, what's the story about, in your own words, and B, add some details to the sketch. So for example, you might notice that they're 24 miles away. Once you've done that, you can move on to C, that asks you, what is the math information in the story? And this is just going to help you get in the right headspace for when we get to E. It skips D for some reason. But once you've done A, B, and C, press play on the video, and you'll be ready to talk about the real gritty part of this problem. So we need to figure out, after 1 hour, how far apart will Kieran and Claire be? And this table is a really helpful resource. Notice that we're calculating time in minutes. And we know that after 60 minutes, or 1 hour, Kieran has traveled 3 miles. So I'm going to go ahead and put that in the table. Kieran has traveled 3 miles. And we know that Claire has walked 3.4 because Claire walks 3.4 miles per hour and Kieran walks 3 miles per hour. So let's think about what's happening here. At the start of this situation, Kieran and Claire are 24 miles apart. I don't even need that line. I can just write 24 miles. And after 1 hour, we know that Kieran is going to walk 3 miles. And we know that Claire is going to walk 3.4 miles. So the question is, after that 1 hour, how far apart are the two girls? Well, we know that we've chopped off this part of the distance, 3 miles, and this part of the distance, 3.4 miles. So what we're really doing is we're taking our starting distance of 24 miles and we're subtracting 3.4, because that's how far Claire walked, minus 3, because that's how far Kieran walked. And that will tell us that the girls are now 17.6 miles apart. I'm going to go ahead and put that in my table. Now, notice that the table also has a space for 30 minutes. Now, if we know that Kieran walks 3 miles in 1 hour, in half that amount of time, in a half an hour, we know that Kieran walks 1.5 miles. And we can do the same thing for Claire. If Claire walks 3.4 miles in 1 hour, in half an hour, 3.4 split in half or divided by 2 is 1.7. And we would calculate their distance apart in the same way, because instead of Kieran walking 3 and Claire walking 3.4, this time we know that Kieran walked 1.5. So instead of subtracting 3, we would subtract 1.5. And we know that Claire walked 1.7. So we would subtract 1.7 instead, which would give us their new distance apart, 24 minus 1.5 minus 1.7, which is 20.8. Now, the next slide on Desmos that we went over as a class just had a bunch more rows in this table. And the other difference was that instead of counting by minutes, they asked you to count by hours. So it was labeled like this by hour. So 30 was 0.5 and 60 was 1. Now, if the girls traveled for another half an hour, there's 2 ways we could solve this problem. The first way is that we know if Kieran walks for another half an hour, she's going to travel another 1.5 miles for a total of 4.5. And if Claire walks for another half an hour, she's going to travel another 1.7. So a total of 5.1. And then we could just do the same thing that we did up here, right? Because this time, and I'm going to erase it so it doesn't get too confusing, after an hour and a half, we know that Kieran has traveled 4.5 miles, and we know that Claire has traveled 5.1 miles. So to find their distance apart, we would simply subtract 24 minus 5.1 minus 4.5, and that's going to tell us how much is left over, or their remaining distance apart after they've traveled for, in this case, 1.5 hours. So we can put that in our table here. Now, the other way that we could solve this is you might notice that each time Kieran and Claire travel another half an hour, so here we're adding another half an hour, Kieran walks 1.5 more miles and Claire walks 1.7 more miles. So in the picture, it would look like this, right? Instead of 4.5, we're going another 1.5, and this is in a half hour. And it's the same thing over here for Claire. In a half an hour, she's going 1.7. So instead of starting from scratch and calculating these numbers in the table, which we could definitely do, instead, I could simply say, okay, in 1.5 hours, she's traveled, or they have, 14.4 miles between them. And if they travel for another half an hour, Kieran is moving 1.5 miles closer. Claire is moving 1.7 miles closer, which means that we're going to end up at 11.2 miles apart. This time, of course, in 2 hours. So we were at 1.5 hours, then we were at 2 hours, and all we did was we said, okay, to get from 1.5 hours to 2 hours, we know how far they travel in that extra 30 minutes. So we could go ahead and put that number, 11.2, in our table. Now, if we did it the way we were working before, and I just added 1.5, and I added 1.7, and I subtracted those numbers, 6 miles and 6.8 miles from 24, which is of course where they started, that would also work. But this strategy simply allows us to work down the table without calculating these middle rows. And you'll notice that on Desmos, you don't have the middle rows as you get to the higher amounts of time. In Desmos, your assignment should pause there. We didn't get to part H, and I think there's a K, or it goes far down the alphabet. If you have questions about this, please see me during office hours so we can keep working on it together.